All right, good morning, everyone. I hope your weekend was nice. Mine was pretty great. So today we're going to be doing Wikistack testing, the one and only workshop that is focused on testing, which is kind of unfortunate because in sort of contemporary software engineering methodology, testing is extremely important. So my first question to you this morning is why? Why do we write tests? So like uncover and edge cases, ensure proper behavior. Okay, but I can do that just by like going and following some flow through the application that exercises that edge case. Say more. How does it keep us from writing excess code? Because it seems like we're writing a lot of excess code to test.
Rather than like working based on, I don't know, I think writing tests allows you to think about the problem before you actually like do the problem.
Yeah. So sort of shape our cognitive processes or shape our thinking. Understand the problem before you start working on it. And this is particularly the case with like test driven development, TDD, where you write the tests before the code. If you write it after the code, it didn't really inform your thinking on the code, probably. I saw more hands up. Maybe. Okay. Yeah. So why write them as code? Why not just do them manually? You test a case, you're like, okay, 0 is an edge case, right? Like the empty set, whatever thing we're working on, the empty set is an edge case. I'm going to test it with the empty set. Okay, it works. And now it works. So why did I have to write 100 lines of code? Yeah.
Because maybe if you have a bunch of different tests that work together, like experience in our last test spec, home test, you can have certain test specs, but then you might have other ones break because they all kind of rely on each other. So this way it ensures that the application actually flows together and works together.
So sort of ensuring the things integrate properly.
Kind of, yeah.
Yeah. Although I think I can also test this just manually, right? Like if I'm using the app and I'm going to use it end to end, I just have to like use it in the right ways. Right. And what are they going to do when they work on the code? Yeah. So it like keeps the code working as the code changes. Or really, it tells us when we break things. Because we definitely will break things, because that's what happens. At this point, you know that's what happens when you work on code. You don't like add one thing and then it all works. It's like you add one thing and then 5 things break because you didn't think about them. And if you have to manually test everything, then you are definitely going to miss parts of your app that you've been breaking. Which is probably going to happen to you during Stackathon and Capstone, because you probably won't write enough tests, because that's just how it goes. I shouldn't say this. I shouldn't develop this sense of fatalism that if you write tests, you will probably have a more robust app. But then there's also a cost to writing tests, right? The dark side, which is that they take time, right? So if I'm writing tests if I'm writing tests now, I'm not writing features now. Which is like, it's very short-term thinking, but if you're working on a short-term project, this is like why like hackathon projects usually don't have a very well-developed test suite, because in your final presentation, which happens 24 hours after the thing is assigned, you don't want to get up there and be like, look, we wrote this completely tested thing. It doesn't do anything very impressive. 100% code coverage, everyone. because it's not the goal. And here projects kind of have a similar, like, you have a relatively close deadline, and the deliverable is ultimately a video showing a product rather than like a finished product that someone's going to keep developing, and so short-term thinking sort of dominates. This is all unfortunate. I'm calling it out because you're likely to fall into this and not write a ton of tests for your project. I really hope I'm wrong about that, but you shouldn't feel too bad about that because we're kind of structuring the environment to like make that the easiest path. Okay, sorry. Questions? Yeah.
When you say manually testing,
Yeah.
meaning like how you were doing with yesterday, like literally checking if the website works.
Yeah. Yeah. And and that's actually another thing. Like, why do we? I should say, why do we write tests? Like manual testing, that probably got tiresome at some point, right? It gets tiresome. So writing a test is usually much harder than manually testing something once, but then it's written, and at some point, manually testing things becomes like you have spent more time clicking through a set of menus than you would have just writing the test. And at the end of having clicked through menus 500 times, you have nothing at the end of writing a test. You have a test that means you never have to manually click through those menus again. So it's an investment in your own future happiness. Okay, let's talk about the kinds of tests. What are the different sorts of tests we might write? This might be not in any reading we've given to you. So one kind of, oh yeah.
Some like types of, so let's see, I want to say that's a function, or I want this function to return an array.
Yeah, so like testing the shape of the code. This is the sort of testing that is irrelevant in strongly typed languages. So basically, the compiler does it for you. These are, I would say, you know, your moderate value tests. Value low to moderate, cost low. It's like really easy to write them, and they test things that are mostly not likely to be broken or mostly not likely to start breaking. Yeah. Yeah, so integration tests. How do different pieces fit together? And then there's testing on the individual pieces, right? So testing the shape of code is usually a kind of unit test, where we're like, what is this, for every input-output pair, right, example, ensure the correct behavior. And a thing is usually a function, usually. And then integration tests, we might try and do sort of a bigger thing where we actually, like, in a fake web browser, go to the website and try and find a button that looks like something and click on it and see that we get the right page back. For a unit test, we might just call the individual functions that are implicated in that flow and be like, okay, if I call you with, like, this event, do you do the right thing? And that was kind of a front-end example. Today, we're going to be focusing on back-end testing, which is, generally speaking, easier. It is a little bit more of a pain, usually, to rig up front-end components to a testing framework because many of them kind of expect there to be a whole browser around them, and that's the pain. It's like a pain to simulate the effects of a browser. React makes this a bit easier because you can just be like, does my React component return the right React things? And those are quite easy to simulate. And then and then you trust React to make the React things do the right thing in the browser. Okay. That's a nice like overview of testing. Let's look at a quick example of writing some tests for a Express server. Oh god, what did I do? Too big. Okay, so I've got nothing in this folder. Let's npm init something. I'm going to make a Fibonacci server, Fibonacci-D, which is going to serve the Fibonacci numbers. And I'm going to do it with test-driven development. So let's use Express. And let's also use Mocha and Chai. I'm pretty sure that's what we're using in this workshop. So there are different ways to organize your code when you're writing tests. Like, where do you put the tests? There are two schools of thought on this, and I think I'm in a different one than this workshop is. I like to put the tests in a file name. Like, I want to put the tests for foo.js in a file named foo.test.js that lives wherever foo lives. They're friends. They're right next to each other. The reason I like that is because it answers the question, where does this test go? It's like right next to whatever it's testing. I think this workshop has a tests directory or a test directory, and all the tests go in there, which is another fine way of doing it. So we will do that right now. Okay, in our package.json, we'll say that in order to test, we should run Mocha. And then in our test folder, let's create a test. I think the first thing I want to do is, I'm writing a web server where you can go to like /1 and it returns the first Fibonacci number, /2 returns the second one. So I think first I need a function that generates the Fibonacci sequence. So let's write that. And I'm going to create test Fibonacci.js, fib.js. I should call this fib.spec.js, I think, just for fun. Okay, so the way, here, let's look at the packages I installed first. So I installed Chai Express and Mocha. Express is obviously going to be what we're using for our web server. Don't have to worry about it right now. Mocha is our test runner. So the test runner gives you a few functions that let you set up tests. The way all JavaScript test runners work that I know of is that they give you some function. They give you functions that you call with a string description and a function that constitutes the test. So most test runners expose one function called describe, which takes the title of a test suite and then a function that, when called, sets up all the tests for this test suite. And then it also provides an it function, which actually creates a test, which also takes a title. So it returns 1 when called 0. I guess maybe I should test one thing first, which is like, it is a function. I'd say it's arguable whether this is a useful test, but we'll include it. So now I want to test inside of these things that Fibonacci is a function and that it returns 1 when called at 0. So I need to do two things here. First, I need to import, or I need to require this function. So require, I don't even have the file yet, but it will be in /fibjs. And I need to test that it's a function. So there's a bunch of ways I can do this. One is that I could use the built-in assert module in Node and be like assert type. Let's see, assert dot equal, yeah, type of Fibonacci function. It's like a reasonable way to do it. I think this workshop uses Chai, which is a library that gives us basically the same kind of tests, but in a different style. So I can require Chai, and oh, sorry, it's I say expect equals require Chai, and then I can say expect Fibonacci to be a function, I think, is actually how you do it. So let's try both of those. If I run npm test, it's probably going to bomb when it tries to import this file. Yep. So great. Already my tests are helping me, telling me that I need to create this file. Can run it again. Okay, so object isn't a function. Which is correct, right? Like this, every module exports an object by default. I'm not exporting a function, and so this test is catching that fact. This test is passing wrongly because there's just no assertions in it. All it means for a test to pass is that it didn't throw. So there's a kind of problem your tests can have where they fail to test anything meaningful. Which is why the test-driven development process is to write a test, watch it fail, because at this point you've just written the test, you haven't written code to support it, the test should be failing. That tests the test, making sure that it's testing the correct thing, or at least testing something that doesn't work when the code that supports it isn't there. And then you make it pass, at which point the test is testing the code. So in a sense, test-driven development is a structured way of forcing you to write the code twice from different angles, which gives us more confidence that we wrote it correctly. Okay, let's make these pass. In fib.js, I'm going to, oh, the other thing you do is you write the absolute minimum you have to in order to make the test pass. So module exports equals, it just has to be a function. There. Now it's a function. And now when I run this, expect is not a function. That's, really? What is it? Oh. Okay, I guess expect is in Chai, not... Oh yeah. Okay, sure. I guess you have to pluck it out. Okay, great. So this was failing, now it's passing. This test is spurious. I shouldn't have written it yet, actually. So now let me write it and watch it fail. Oh, also, let's, both of these are running right now. I'll include this just so you have a reference for it. Assertion-based, assertions. These are, here, these are assertion style checks. These are called behavior-driven development style checks. And this is what the workshop uses, so this is what we'll be using continuously. But you can also really just say, like, if type of Fibonacci is not a function, throw new error. Fibonacci must be a function. This is also a valid test. Let's break it again. And this kind of thing, this is all that, oops, Fibonacci. This is all that Chai is doing, really. It's doing this in a particularly convoluted way, but it's basically a way to access code that checks something and then throws an exception if it fails. Style. Yeah, it's like the difference between like assert something and expect blah to blah blah blah. It's just stylistically what is preferred. I actually slightly prefer assertions, but this workshop prefers BDD, and I think you'll see more BDD in the wild, probably. Okay. Totally manual assertions. So these are very clear as to what's happening, and a bit too clear. That is, if you wrote tests, if all your tests looked like this, your code would be pretty long. Your tests would be even longer than they already are. Assertion, style checks, and then, oops. And then BDD checks. Okay, and this is what we'll use right now. So let's make sure my tests are still passing. It's not, oh right, because I broke it. Already our tests are helping us. Oh, and instead of continuously rerunning npm test, I can do npm test minus w. This minus tell here. This minus tells npm stop processing command line arguments and instead take all the rest of the command line and give it to whatever command you're about to run as the test command. So in this case, give it to Mocha. And then -w tells Mocha to watch the file system for changes. So when I run this, it's going to not return. I have no command prompt, but every time I change something, it's going to rerun the tests. Which helps you get into flow.
How do you turn it off?
Yeah, I just Control-C to kill it. Yeah. All right, so it returns one when called with 0. Let's actually write that as a test. So expect Fibonacci of 0 to equal. Okay, so Chai has dot to equal, EQUAL. That is a double equal, or to EQL, which is to triple equal. This is one of the things that I'm like, is this an improvement over just having a double equal sign or a triple equal sign? I don't know. To equal 1. Okay, so now our spec is failing. Fabulous. Expected undefined to deeply equal 1. Okay, so I can make this test pass. The minimum work. Okay, and let's write a couple more. It returns.
So you're supposed to write your code as you go. Like
Yeah.
you're supposed to write a test to make it pass however you can, and then write another test.
Yeah, I'm being like a little dogmatic about this. Like maybe you would actually write the Fibonacci sequence at this point, but you know, until the spec makes me do it, I'm not going to do it. And you can go totally crazy with this, right? Because I could. Anything I'm testing is necessarily going to be less complete than the full range of things the function should generate. and if I'm really pedantic, like here, like we'll see. If I'm really pedantic, then I'll just like write my function as a lookup table for all the things in the test. But at some point, like, don't do that, right? Write the minimum amount of code to make it pass also means if your lookup function is 20 lines long and the actual code would be 1 line, write that 1 line instead. So let's see. I'll return 1 when called with 1. Still passing, great. And then 1, 1, 2, 3, 5, 8. So returns 8 when called with 6. Oh, right. Fibonacci of 1 should equal 1. Fibonacci of 6 should equal 8. Okay, this is now failing. And probably, so I could have some crazy check here where it's like, oh, if n equals, if n equals 6, then return 8. But this is the point where I'm going to say that's crazy and just do the right thing. And what is the right thing? So if n is greater than 1, then return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Otherwise, return 1. Yeah. Oh, I should call this something. And I just learned that there is a off by 1. Really? Returns a 1, 1, 2, 3, 5, 8. Oh, I'm right. Sorry. This is 0. That's the problem. Okay, cool. So everything is now passing. What about negative numbers? It's kind of not well defined. The test doesn't test them. Right now, we have behavior on them. It's 1. It always returns 1 for a negative number. That seems fine. I think opinions might vary on whether you should test that. Test for like behavior that doesn't matter right now. You might come to rely on it somehow in some way, so it can be useful to test. And so I'll take the stance that we probably should test that, as it returns 1 for any negative number. Expect Fibonacci of negative 100 to equal 1. Here I'm encoding existing behavior into a spec, so it's not failing. Technically, we maybe don't have total confidence in this spec, but this is kind of a dodgy spec to begin with, so that's all right. And then I might have another, I like to have some test that's like a little bit more holistic, so I might say like it returns the first 10 numbers of the Fibonacci sequence. And here I might do something like new array of 10 dot map the fill it with some arbitrary thing, 0, map those numbers to Fibonacci of I. So map actually the indexes to Fibonacci of I, and expect this sequence to deep equal So this says look at everything inside of this thing rather than just do a triple equal on the array itself. 1, 1, 2, 3, 5, 8, 5, 5, 8. Oh my god. 13. How many things do I have? 1, 2, 3, 4, 5, 6, 7. Help me. 21, 34, 55, 89. That's got to be it, right? Okay, let's see. Okay, we got one too many. Okay, and then I guess we already saw it fail when the sequence is wrong. So that's like a pretty complete test of the Fibonacci sequence function, I think. Oh, there's one other thing I could be checking, which is this thing is extremely inefficient. I could try and make it more efficient. It's actually a little bit hard to test that. Like, I would have to, if I wanted to say like it runs in O of n time rather than O of e to the n, which is its current runtime, I would have to like instrument the Fibonacci sequence. But what I can do is use the fact that I have tests to like improve the performance of this without worrying about having broken it, because I know that the specs are passing, so it's working. First I'm going to commit this. Fibonacci function tested. And then I'm going to optimize this by saying that first, if n in fib, right? So if we have previously computed this number, then we'll return it. Otherwise, we will assign it and return that. Okay. I think this doesn't change, right? Yeah, and I think I do have to do that. So this is using memoization. This says that if there's literally the property n, so if I call this with 5, if 5 is a property inside the function object, then return whatever that property is. Otherwise, assign that property to be the value of this function called with that. This means that we don't have to recompute. There's like a lot of recomputation going on when we call Fibonacci, right? We have to, whenever we're computing n, we compute n minus 1 and n minus 2, and then computing n minus 1 requires us to compute that n minus 2 again. So we're duplicating a huge amount of work. This way we don't duplicate that work and instead cache it. So it turns what is an exponential time algorithm, something that we could not call on like fib of 1,000, to something that we can easily call on fib of 1,000. Okay, so let's now, and I guess we could say like, actually here's one thing here's one way we could test that. I'll stash my changes, and then let me write a spec that's like it returns for fib of 1e5, so like 10,000. And I'll just expect fib of 10,000 Fibonacci, 10,000 to equal 3, but honestly what I'm checking here is that it doesn't crash, which I think it's going to. Yeah, total bomb.
Could you do, like, rather than the 2 equal, a type of output? So, like,
Oh yeah, I could be like, to be a number. Like, we don't care about the result, we care that there is a result. Yeah, that's a good answer. Okay, and so now we'll fix it, get stash pop, will get me back the memoized version. Which still fails. Is it too deep? Oh, it might actually be too deep a stack. Let's just try 1,000. That's a different problem that we'll have to manage. Okay, but then okay, great. So this is not going to return. Spoiler, it's going to crash at some point. But then if we get stash pop, it returns. Yay! That's awesome. So now we have some confidence that this is doing something, and we have more confidence that it's doing the correct thing because all of these are still passing. So we can say this is memoized Fibonacci. I don't have an ordered master. Okay, so that is half of it. Next, I'm just checking on time here. Okay. So next we want to write the server, and to do that we need to write some tests of the server in order to justify us having a server at all. Testing backend routes is a little bit more complicated than testing a pure function. Testing pure functions is sort of delightful because you call them with the things they need and you check that they return the right thing. It's like it's a very pure test. We're going to do a similar thing for routes, but to call them, we're going to sort of fake an HTTP request to the server, and we're going to ensure that the HTTP response is what we expect it to be. Doing that manually would be pretty irritating, so there's a library called supertest that we can install. Also, I just realized I did npm install -- save, which what I should have done is say npm install -save dev. So I'm going to move 2 of my dependencies to dev dependencies. The reason we separate them is because we don't actually need Chai or Mocha to run this program. We just need them to run the tests, to develop it. Okay, so Chai goes down here. Mocha goes down here. Test is there. All good. Okay. So now we'll create a test server spec.js and fill that out. So we kind of need the same beginning. We need expect from Chai. And we'll need the server, so we'll need our application. Server.yes. It's just server. And we'll need to make sure to export our app from the server, which is fine. So describe the fib server. Sounds like something that serves Donald Trump's tweets. It, okay, so it returns, actually I might write it like this. It, when we get n, or get 0, returns 1. So we're kind of mirroring the Fibonacci tests. Okay, how does this work? I think I need to create, okay, first I need to require supertest. And then I need to give it an app, which I can then call getOn. Okay, so, oh, this is a nice moment to show you before blocks. So another function Mocha gives us is before, which lets us say, hey, before the test runs, do this. And then this can be create a agent that is testing this app. So I think this is how you do it. And then now in each test, I can say agent get /0. But this breaks my auto-completion, which is really irritating. Okay, so you can do this. There are cases where you have to do this when you support login, for example. I'm not going to do this because it takes away my autocomplete, and I don't know how to do this well enough to do it without it. I'll say you can use before blocks to set up things, stuff that needs to run before every test. This will be useful to you in the future. Oh, before all tests. So I can get 0 and then expect. Okay, expect takes a status and then a callback. Then, and returns a promise, I think, which I can. How does this work? Do I have to look this up? I might have to look this up. Here, let's just expect that we get status 200 for now. Is okay. The last thing we need to do is make sure that this is going to return a promise, which is great, but we need to return that promise. So we need to make sure that there aren't curly brackets around around our function body. The reason is that if we don't return this promise, Mocha doesn't know to wait for it, and it'll just keep on running and then say that there were no assertions in this test, and it'll be very confused. So be sure if you have an asynchronous test, something that's testing, for example, accessing a server, that you return the promise from it. Okay, so let's test this.
So we return the promise just by not being intelligent?
Yeah, if you don't have curly brackets around the body of an arrow function, then this doesn't have to be an arrow function. You could type out function and then type out return. But if you use an arrow, then you can omit the braces around the body, and it returns the right-hand side of the expression. And something's wrong. What's wrong? I think I don't have that file that I'm testing. Yeah, I don't have server. Great, so let's create that. Server.js. And let's create our app, and then export it. Okay, expected 200, got 404 not found. Hey, it's working, our test is working. we got a 404, which is great, which makes sense because this server has no routes. So if we add a route, let me just do this, right? Get 0, then request response res dot send res dot send status 200. Now my test is passing. Oops. But of course this is insufficient. I need to also test that it's returning the right thing. And I don't remember how to test that it's returning the right thing, so let's look that up. Come on, become full screen. Oh, fine, don't become full screen. Okay. See if I care. Super test. Go to the NPM docs for it. Look at its examples. Wonder why everything is so slow. Okay, so what can we do here? We can get a path. We can expect headers. That's nice. I could expect a certain content length. But actually what I want is to expect the body to be something. Okay, so I can say then I get a response and then I can make assertions on the response. Okay, let's do that. That looks right. So response body email. So I can say get 200 is okay, or get 0 returns 200, get 0 returns 1. So expect it to have a response of 200, and then this response is going to, we're going to expect this to have a body that they're using assertions. To equal 1. Oh, some deep failure. Okay, expected the empty array to, or the empty object to equal 1. Makes sense. Let's try actually sending back something. So I'll send 1. And it got an internal server error. What if I send the string 1? That's odd. Is it not .body for text? Expect set cookie. Body text. Let's see. Oh, I can just say expect a string. Really? Can I do that? Oh, I can. How lovely. Let me make sure that that's working by having it fail first. So I'll be like, send 2. Okay, now it's failing. But if I send 1, it passes. Great. So we could duplicate all of the Fibonacci tests. It's not really that useful because we're already testing the Fibonacci function. So I'll just say maybe it get 100 returns fib of 100. Get 100 expect 200 as the status, and then expect this to equal fib of 100. As a string. I actually haven't imported it into this file at all, which is why it's mad blowing up. Fib is not defined, but I can import it. So let's fib equals require fib. We can call it whatever we want here. So I'll call it that. Oh, now it's not found because we have this stupid route rather than a smart route. So let's actually make this work. We'll say that this is n res.send fib of n, and we'll import fib in. So fib equals require. And this should probably be a string when I send it. Expected okay, got an internal server error. Oh, this has to be rec.params dot n, and I probably need that as a number. Great. Oh yeah. Oh yeah, it turns it into a number. As opposed to a string, because otherwise everything in params starts out as a string. Yeah. You could also be like number of rec.param. It's probably what you see more often. Yeah.
So are you forcing the rec.param.n number?
I'm coercing it into a number, and then I'm coercing the return value of fib into a string. Because if I call send with an... actually, maybe I don't have to do that. Let's see. Yeah, if I send a number, I think Express thinks I'm trying to do something else. But if I send a string, it's like totally clear to express what I want to do. Let's add one more spec, which we'll just say it returns the first 100 Fibonacci numbers at, how about get / returns the first 100 Fibonacci numbers. And here I will use a function body because I'm going to first create what we want that to be. So we'll say new array, 100 things in it, fill it with zeros. Map all of its indexes to... This underscore is just me saying I'm not using this. Map it all to the Fibonacci sequence, and then just join it with commas. And so now we can get / and expect it to return 200 and expect that to be sequence. Which it won't be because it'll be 404 not found, so we need to add that test, or add that route. And I think it's kosher to just grab some code from your spec to fill out your server, or to fill out your code. That's fine, right? Great. And now, when we actually start the server, which we have not yet done, Supertest actually kind of fakes hitting the server by calling the routes directly, or rather by calling the Express handler directly. But now we can make this server runnable. So we can say if module is require.main. This check says if I was run with node at the command line, so like I said node server, then app.listen on a port, which I'll say should be process.end.port or 1307. There's got to be, how about 1135? That's a nice port, right? For this. So now if I run node server, it doesn't print anything. If I go to localhost 1335, I think with a high degree of confidence, nothing's going to happen. What's going on? Oh, I did. I went to the wrong thing. 1135. There. There's all our Fibonacci numbers, or the first 100 of them. If I want 10, that looks right. And that's not surprising, because we had tests for all of it. Yes. Which one? The server spec?
Yeah. And just kind of go over what you were doing in that last one, the server spec with the first 100.
Yeah, so first I'm figuring out what the first 100 Fibonacci numbers will be. So the recipe I'm using for that is I create a new array with 100 spaces. You can just use the array constructor for that. I use the array fill method to fill it with zeros. The reason I'm doing that is when you create a new array using this form, all of the elements in it are undefined. And when you map ignores undefined elements. So you can't just do new array.map. You have to first fill it with something, in this case zeros. And then I'm going to map over, so I'll map over every element. I'm going to ignore the value, which I know is just 0. But I'm going to take the index and map it to the Fibonacci function at that index. So that returns an array of the first 100 Fibonacci numbers. And then I join that with commas to get the string joined with commas out. And then I'm going to test that when I get the root of my server, it returns that. It returns 200 with that body. And the fact that we can use the same function for this is just an artifact of how supertest works. If you say expect a number, then it expects that to be the status code of the response. If you say expect a string, which this will be, then it assumes you're expecting that the body of the response is that.
So this one has
Oh, it does? Wait. It does. Oh, but I'm returning it. Yeah, yeah.
Right. Did you, so you made this test, did you change on the server one, so have you got every single one as an option, or how is it?
Every single...
Like, so there you just did the 100, you keep above it, like,
yeah.
If you go to slash, it will give you 100, right? So if you wanted to...
Yeah, if I go to slash, it gives me 100 of them. If I go to, like, slash 50, I just get my 50. So I could set up a little bit more stuff here, right? Like our app could have some logging and this or that, and I wouldn't necessarily write tests for that. It's kind of pointless. I think it's kind of pointless to be like, the app has a logger installed in dev mode. It's like very hard to test, and then very low value. Partly because you'll know if it's not there, because you won't see the log messages. Okay. Any other questions? Pretty similar. Jasmine has, but there's, I don't know if there's a great reason to switch. Mocha and Chai are maybe slightly more popular in the React world, although maybe Jest is actually more popular in React world. Anyway, a lot of later workshops use Mocha, so that's why I used it up here. They're pretty similar. The main difference is that Jasmine has an assertion suite built in. So like Jasmine provides like expect equals, expect this, and Mocha does not. You have to use Chai or some other library, which does mean that Mocha is more flexible because you can just use Mocha to set up the test and then use whatever you want to do the assertions inside of it. Jasmine kind of also works that way, but it's designed to be used with its own library. And now you have more exposure to different testing frameworks. It's a pro, not a bug. Okay, great. Go ahead and like get water and get ready to work. I'll send out pairs.